interval notation is a new way that we can list out numbers, an infinite set of numbers, without having to list them out and without having to graph. And if you think back to one of the original videos that I did with inequalities, the entire reason that we were graphing the solution set to an inequality was because we didn't want to sit here and we didn't want to have to write all the numbers that satisfy an inequality. That's why we were graphing. So now that we've learned how to graph, we're also going to see that we can write a series of numbers without having to graph, without having to list them, and that's what interval notation does. And you'll see interval notation where it just gives you the beginning number that satisfies an inequality and the ending number. So the smallest and the largest number that satisfy an inequality, and then we just assume that whatever's in between these two numbers will also satisfy the inequality. What you obviously notice here is that some of these have brackets, some of them have parentheses. Well, that's just telling you whether or not the number is included or not, just like when we had open circles and closed circles. So in this first example here, A, B, and they both have brackets, this just tells you that your solutions X are between A and B, and it includes A and B. So it's greater than or equal to A or B, and less than or equal to A and B. Okay, so that's why brackets always symbolize or equal to. When you have parentheses, that's just telling you that those numbers aren't included. So this tells you that X is between A and B, but does not include A and B. So this one, you just got to be a little bit careful. Parentheses always exclude the number. Down here we have A and B and X in the middle, but we see that B is included and A is not. So the numbers between A and B, including B, but not including A. And finally down here, the numbers between A and B, including A, but not B. Now, you don't have to sit here and just memorize this, and I don't want you to sit here and memorize these four things, but just practice them and get used to it. It's just telling you the smallest number, A in this case, that satisfies an inequality, all the way up to a largest number. So let's go to the next page and do an example. So here's an example that you will see. Solve, graph, write the solution in interval notation. So remember when we solved this, we treat it just like it was an equation. You just have to be careful when you're multiplying and divided by negative numbers. So we can subtract 7 without any problem, and we get negative 2x is less than or equal to 8. And now to get x by itself, we divide by negative 2. Now there is something we need to be careful about. We must switch the inequality sign, and we see that the numbers that satisfy this inequality are all of the numbers that are greater than or equal to negative 4. Those are the numbers that satisfy this inequality. So if we wanted to graph this, we would draw our number line. We would mark 0, we'd mark negative 4 with a closed circle, and then we want all the numbers larger than that, so we shade to the right. Now, using interval notation, we still want to graph to compare our solutions here, but we don't really have to, because we can write the smallest number that satisfies the inequality, comma, the largest number that satisfies the inequality, and we're going to put that between parentheses or brackets depending on whether or not that number is included. So if you look here, the smallest or the least number that is shaded is negative 4. That is the number furthest to the left on the number line that is shaded. So that's where we're going to start, negative 4. Now we have to ask ourselves, is that included? Does it have an open circle or a closed circle? And we see that negative 4 is included. So since it's greater than or equal to, and we are including that number, we're going to have a bracket. Now what's the largest number that's shaded? Well, let's say here's 100. Well, what about 101, 102, 103? This is going to go on forever. So what we do is write the sign for infinity. And it just looks like a sideways 8. That's the symbol for infinity. And it just tells you that all the numbers between negative 4 up to infinity, that will go on forever, are going to satisfy this inequality. The last thing we just have to be careful of is we don't have, and you may be saying, well, we want to put a bracket because infinity is included. Well, infinity really isn't a number, so we can't include it. We can't say infinity is shaded because it's not a number on the number line. So always with infinity, we will always use a parenthesis. Always use a parenthesis with infinity. Let's look at another example. Now we want to take this graph, this number line, and write it in interval notation. So we can see that this particular graph has all the numbers that are starting at 17, not including 17, and all the numbers that are less than 17. So to write this in interval notation, we always start with the smallest number. The smallest number, or the number all the way to the left, the furthest to the left that's shaded. So if this were, we can see by the arrow, this is going to go on forever. So instead of, we're going to see that that's not going to be a number on the number line because it will always continue on, continue on. So instead of talking about positive infinity, we can actually say, well, this is going to go to negative infinity. And since we don't use a bracket with negative infinity, we want to have a parenthesis. So the smallest number, or the number furthest to the left that's going to be shaded, is, well, negative infinity. And this is going to go, starting at negative infinity, then all the way up to 17. So, comma, the smallest number is negative infinity, all the way up to 17. 17 is not included, so we have a parenthesis. So that's how we take something using a graph and write it in interval notation. So to summarize, interval notation allows us to write a sequence of numbers or an infinite number of numbers without having to graph something or having to sit here and list all the numbers that satisfy a given inequality. And we do that by listing the smallest number that satisfies the inequality and listing the largest number, and we just assume that the numbers in between also work. Where you have to be careful is the ends. Are you going to have a parenthesis or bracket? And in order to determine that, just look to see if it's included. Is it a greater than or equal to or less than or equal to? If it is shaded with a closed circle on the number line, it will have a bracket. Otherwise, it'll have a parenthesis. And finally, with infinity, whether it's negative infinity or positive infinity, we always use a parenthesis.